So, hi guys. Today in this section, we are going to start a brief thorough in VPC, AWS VPC. But before that, we are going to start some of basic in subnetting in CIDR, what are CIDR, what are networking, right? So let's start with CIDR itself. So what is CIDR in VPC? CIDR means classless inter-domain routing. Classless inter-domain routing. What does this mean? Basically, it's a method for allocating IP addresses. How your IP address will get allocated will be decided by the CIDR block. As in, if you check in AWS console, if you go on this panel, VPC, there is a default VPC created by AWS, right? Let me show you that VPC. You basically click on this VPC section, you will see this default VPC, which is 172.31.0.0/section. And at the above, you can see that it is IPv4 CIDR. CIDR means classless inter-domain routing. Now, inside this CIDR, all your subnetting, all your resources, everything will be launched inside this CIDR. So it will be, you can say that it are segregated from other VPCs. So no one will able to get access on this instances or this resources without the proper permission or anything, right? So inter-domain routing. So basically it defines how will IP get allocate and what will be the IP address ranges, right? So let's start with something like, suppose we do have IP address called, suppose access.yy.zz.ww/32. As you can say in VPC also, there is /16. So what does this /16/32/28/21/012, what does it means? Basically, it means subnetting, right? So 32 means one IP. /32 means it's one IP. So also, if you defined this 0.0.0.0.0/0, it means all IPs, right? Now, see one thing. Suppose you define 192.168.0.0/26. So what does it means? It means IP will have this range 192.168.0.0 from this to 192.168.0.63. Now the question comes, how we are able to define this IP will come inside this CIDR or this subnet block. So basically, if you check in CIDR, your CIDR consists of two components. First is base IP and second one is subnet mask, right? Base IP, if you see this IP, base IP would be 192.168.0.0. This will call as the base IP, right? 192.168.0.0 will call as base IP, and /26 will call as subnet mask. Basically, it defines how many bits can be changed in the IP. Now the question again arises, what is bit? So this base IP is made up of 4 octet. If you check this 192.168.0.0, all this IP consists of 4 octet, and each octet consists of 8-bit. IP consists of 4 octet, and each octet consists of 8-bit. So what does this means? See, if you check, let's check the example itself. Suppose you do have IP 192.168.0.0/32. /32 means all IPs are there, means it allow only one IP. It will have only one IP. And how does it, we are able to know that it will only provide one IP? See, let's divide this 192.168.0.0 in different parts. 192, and we have 168, and we have 0, then we have 0, right? For this 192 octet, we have 8 bits. Again, for 168 octet, we have 8 bits. Again, 0, we have 8 bits. And again, this for this 0, we have 8 bits. If you add all these 4 octets, 8 plus 8 plus 8 plus 8, it will be 32 bits, right? So that's why I called 192.168.0.0/32 meant all octets, all subnets are full. All bits are full. So this will define only single IP, right? Now, if we check another IP, 192.168.0.0/31, this IP, it means it's one bit is free. /31 means first 8 bit is full, second 8 bit is full, third 8 bit is full, but at the fourth octet, first 7 bit is full, last bit is empty, right? As we have already seen on networking, we have 4 bits like this, 8 bits, 0 0 0 0 0 5 6 7 8, this way. So if you check for 192, the subnet will be 1.1, subnet will be 1.1.1.1415678. This will be subnet mask of 192. Same for 168. This will be the subnet mask for 168. For 0, we do have subnet mask for 10 will be this. But for last 0, it will be 4, 5, 6, 7. For 8, it will be 0. Because this bit is not fully established, means if this bit is not fully used. So if you check, we do have last bit remaining on this 4 octet. So there is the formula to get to know what will be the total IP, that is 2 power n, and where n is equal to remaining bits, right? So if we check on this also, if this on this IP also, 192.168.0.0/32, at 32 means all the bits are full, means there is no remaining bits. So 2 power 1 equal to means sorry, there is no bit remaining, means 2 power 0 equal to 1. Anything's power equal to 0 equal to 1. So we already told that as its power equal to 1, then IP will be, check the IP. The IP will be this only, 192.168.0.0. This will be your first IP. Now check for the second one, 192.168.0.0/31. For this, last 1 bit is free. First 3 octet are full, and last 1 bit is free. So 2 power 1 is equal to 2, means we do have 2 IPs, and the IP ranges would be 192.168.0.0 from this to 192.168.0.1. Right? Now let's come to third one, 192.168.0.0/30. This time subnet is 30. So how we will able to know how many IPs are there in 30 subnet? So see, again 2 bits are empty. First three subnets are full as it's 30, and for the last octet we have 2 bits remaining. The 2 to power 4 is equal to 2 to power 2 is equal to 4. Now we have 4 IP. So IPs would be 192.168.0.0 from this to 192.168.0.3. First four IPs from 000 to 003. Same if you go for /29 this time. Now /29 means obviously first three octets are full. For fourth octet, we do have 1, 2, 3 /32 minutes. 3. We have 3 bits which are not full. So 2 power 3 is equal to, if you check what 2 power 3 is equal to 8. Now we do have total IPs of 192.168.0.0 to 192.168.0.7. Right? Again for /20 suppose we have now /26. Sorry, /928. Now for 28 again we do have 4 bits are free. First 3 octet are full, and at the 4 octet first 4 bits are free, and first 4 bits are full and rest 4 bits are empty. So 2 to power 4 is equal to 16. Right? So IPs would be 192.168.0.0 to 192.168.0.15. This way. Again for 27, if you check, same things happen. For 2 to power 5, the total IPs would be 32, and the IP range will be 192.168.0.0 to 192.168.0.31. Same thing happens for each subnet. Now suppose you do have subnets called 192.168.0.0, but instead of this this subnet mask, we do have 24. 24 means first 3 octet are full. 8, 1 8, 8 2 16, 8 3 24. The first 3 octets are full, but at the 4 octets, this octet are empty. Means it's 2 to power 8. So what will be the 2 to power 8? It's 256. 2 to the power 8 is 256. Means we do have total IPs of 192.168.0.0 to 192.168.0.253. Right? Because we do have 2 to the power 8 is equal to 256. So it will be 255. Sorry. Got it? Got it, guys? So also you can check this also. There's a website called IP address guide. You can just type this ipaddressguide.com. You can check this website. You can just define CIDR block here, enter IP address or anything here. Everything will be fine. Sliced. I just missed one thing. CIDR. I think this would be yeah. This one is fine. CIDR. Right. Suppose now if you check on this VPC 172.168.0.0, if you check this /16 means first 2 octet are full and rest 2 octets are empty. Means 2 to the power 16. And if you check 2 to the power 16, it will be 65536. Right? If you check, suppose we do have 10.0.0. Suppose check for this CIDR block only. Just copy this, paste it here. And if you calculate this, see, it will give total 65536 host. Right? Your first host will be 172.13.0.0 and your last host will be 172.31.255.255. This way. So if you check on this VPC, we do have a CIDR block of 16 and total IP address we do have 65336. Right? So now, this is the way we are able to define what will be the CIDR blocks and how we are able to how many IPs we can create inside this CIDR block, right? Now, let's come on to the topic where how AWS manage all these kind of stuffs, right? So inside this AWS, we do have default VPC, and this default VPC internet connectivity is there, right? And in a region, maximum you can create 5 VPCs, right? It may comes in interview or sometime in exam also. How many VPCs can be created? Default VPC can be created in a single region. So in a single AWS region, we can only create 5 VPC. But yeah, we can create more VPCs. We need to create a ticket to the AWS to increase our threshold value for this. So by default, there will be a 5 VPC. You can create maximum of 5 VPC in any region, right? So now we will start some practical in this VPC. So we do have this VPC 172.31.0.0. We will not create anything inside this VPC. We will create a new VPC, right? Let's create one VPC only. Inside VPC, let's define a VPC called CIDR clause 10.0. It's a name. Sorry, we need to define first name. My VPC. Let's define it as my VPC, right? And what will be the CIDR block? Let's take it at 10.0.0.0/16. /16 means 2 to the power 16, right? So 2 to the power 16, as already told you, it's 65536. Total host will be 65536. But this point should be remembered that only AWS used to reserve first 5 IPs, not first some 5 IPs as for the future perspective. Suppose we have defined this in a /10.0. Let's make it some more small, /24. Let's take it as /24, right? So if you check for /24, it means 2 to the power 8. So it will be called 256 IPs only, right? So if you check for this CIDR block 10.0.0/0/24, we do have total of 2 to the power 2 power 2. I don't know how to make the power sign here, so no issues. 2 to the power into 2 to the power 8 will be 8 to the power 8. So it will be approx 256, right? So now 256 IP, but you will not be able to use the all 256 IP if you are using AWS, right? So first IP like 10.0.0.0, this IP will be used by AWS for network address, right? Now second IP 10.0.0.1. This IP is reserved by AWS router, right? Reserved by AWS for VPC router. Right? Now 10.0.0.2. This will be reserved by AWS for mapping to Amazon provided DNS. Your VPC will be mapped to the DNS. I will let you know how to do that. Reserved for mapping to AWS DNS. DNS means AWS DNS is Route 53. Same .3 would be reserved for AWS future perspective. AWS future perspective. See, 4 IPs are there: 0.0, 0.1, 0.0.2, 0.0.3. And last IP, .255. This will be for network broadcast. Right? So basically, total of 5 IPs. If you create, suppose now we are creating /24 subnet. We are creating a CIDR of /24, right? Let's create it up a little bit bigger so it will be more understand, /16. So floor /16, we do have 65536, right? As we have checked on this, we have 65536. Let's create it. Create VPC.
Sir, I have a question. So you have said that 5 IPs are reserved, right?
Right.
So this is only in the case of VPC.
Yes.
Right?
Right. Because
This is
everything,
only for VPC.
yes, everything would be created with the help of this IP only. How we are able to connect to our any resources inside the AWS means every resources will be provided our IP. So what does this VPC does? VPC used to reserve this first 5 IPs, this all 5 IPs for their own purpose, right?
Okay.
Right. See, we have DNS hostname disabled. If we enable this, so AWS will use that 10.0.0.3, sorry, that 0.0.2 for reserve for mapping to AWS provided domain. If you just click on this action, and there's an option called edit VPC setting, then we can check, see, enable DNS hostname. You can also enable this DNS hostname, right?
Right.
Okay, I'm just canceling this. Right. So now we have created our own VPC called VPC, my VPC, right? So if you check along with the VPC, when we have created VPC, AWS automatically created one route table. See, this will be the route table. Let me check what will the VPC. This is my VPC. Yes, this would be the default route table, which is created by AWS when you created your VPC. What does this route table told us? Route table will help us to define how our traffic will goes from our VPC to our VPC. I mean from inward and to go from outward, from ingress or outward, inbound and outbound. How traffic will come and goes to this VPC will be defined on this route table, right? Route table default. Let me define this my VPC, right? So this is the default route table. Now, if you check on this route table, right? Now, if you check the default VPCs, there is a default VPC called this, and there is route table associated with this VPC, main route table. If you click on this route table, right, and if you check this subnet, you will find an internet gateway. Inside this route, you will able to find this internet gateway, IGW. What does this internet gateway tell us? Basically, it allow your application, your VPC, your application would able, means if you have attached an internet gateway to any VPC, then or any so what happens that outward traffic get allowed means you will able to access your VPC from outside the network through internet. See, now let me show you with the example only. Suppose we have this VPC, right? Let me create one instance. Let me take a duplicate here and let me create an instance here in EC2 only, right? Let's create an instance, launch instance. Right, we are going to launch instance in our new VPC, right? Test. We'll write the instance name will test, and let's take Ubuntu image, right? Let's take 22.4. Everything would be fine. T2 micro would be fine. Keep here. Let's take this key pair as Deva, right? Or just create a new T pair, right? My new key, right? Let's download this .pem, create key. Now key has been downloaded, right? So VPC, let's edit this VPC. Now we want to create our VPC in my VPC, the VPC created by us, my VPC, right? And select subnet. Now see, no subnet found. Either this account have no subnet in this region or invalid search has been made. As we have created the CIDR, right? But have we created any subnet? because we can't create instances or resources inside the CIDR. We need to create some subnets, as I have told you, subnetting in there, right? So we need to create subnets. So before doing this, let's create also subnets. Let's go inside the subnet section. We will create two subnets. One is private subnet and second is public subnet. Let's create one by one. Create. We will create this subnet in my VPC. And what will be a subnet? This let's I write this name public subnet. Public my VPC. Right. And availability zone, let's take it at 1A. And your CIDR block. Now we do have a big CIDR block like 10.0.0.0.16. Let's create a new subnet for this. And we are taking this 10.0.0.0/24. Right? We are taking this, and also I'm adding a new subnet also called first one I've created public. Let's create it as private. Private my VPC. Let's take it as B. Availability zone V. And we are creating this with the subnet mask 10. Subnet IP 10.0.0 1.0/24. Right? We are taking this subnet and let's create. Now two subnets are created. For first subnet, we do have CID block for 10.0.0.0/24, and for second one, it's 10.0.0.0/24. Right? Means now what will be the first IP for this? This IP would be 10.0.0.0, right? And the last IP would be 10.0.0.255. See, if we check this in this, let me paste it here. See, your first IP will 10.0.0.0.0 and last IP will 10.0.0.0.255. Total host is 256, right? But if you check on subnet, it will show total available IP4 is 251. Here it's showing total is 256 IP. But in subnets, it's showing inside this subnet, you can only able to use 251 IPs. Why? Because I have already told you, AWS uses 5 IPs, reserve IPs for this purpose, for their own purpose, right? So therefore, 256 minus 5 equal to 251. That's why total provided is 251. Same for this second subnet 10.0.1.0. Our first IP will be 10.0.1.0 and last IP will be 10.0.1.256. If we check on this in this URL, see, first IP will be 1.0 and last IP will be 1.255. Got it? So we do have two IPs here, two subnets here. And we have created first for the public subnet and second for the private subnet, right? Let me launch this here. Let me refresh this. Yes, we have two subnets here. Let me create this on the public subnet. So auto assign public IP disabled. Let me enable this. Means if we want to allow public IP to our EC2 instance, as we are launching this EC2 instance, automatically public IP will be provided. But still we will be not be able to access this IP. I will show you why. Also, we are let's check take existing security group, but this is for the different VPC setting. No, this is for the same VPC. We will do changes in this VPC also. Let's launch. We will be launching our first instance here. You launch. See, this is our first test instance, right? And if we check, IP would be 10.0.0.116, right? Because we have launched in our first subnet, so they have provided 0.0.116. And they have also provided a public subnet, right? Let me check the security group. Let me allow some rules here. For if we check for inbound rules, protocol, and let me allow this for a particular CID range for, let me allow this inbound IP, added inbound rule. right? Let's say add IP, custom IP. Let's allow SSH traffic, right? And custom, uh, let me allow for IPv anymore, right? And save this. Now we have saved this EC2. Let me copy this public IP. Let me open my terminal, right? Let's go to downloads and we have SSH-I my key. This is our key. Then as we are using Ubuntu here, so Ubuntu @ and IP would be this. See what happened. No connection. Why? Why we are not able to take access on this IP? The reason behind is that as we have allowed this, as we know, we have allowed our IP. Means if you check on security group, we have allowed everything here. We have allowed SSH from everywhere. I have already told you 0.0.0.0/0 means all IPs. We have allowed all IPs for this, but still we are not able to access this EC2 itself. Why? Because we have not provided internet gateway. How public subnet is different from private subnet is because in public subnet we have internet gateways, and in private subnet we don't have internet gateways. If you check on by default VPC, you can check an internet gateway is already allowed. See, if I show you inside this, it's route table. Let me show you. Its route table will show routes, will show internet gateway. This internet gateway will help us to take access to inside our instance from internet. Now we are creating a new internet gateway. Let's create a new internet gateway. We'll call public IG internet gateway or any. Let's take my internet gateway, right? And let's create this internet gateway, right? Internet gateway is created, but it is detached. Means it is not attached to any VPC. Let's attach to the VPC, and attaching with my VPC means, so one thing should be remembered that we can only attach one internet gateway to only one VPC, right? That's why it's not showing another VPC here, only showing one VPC, my VPC, and we have attached this VPC to internet gateway, our internet gateway. Let's check. Now, if you check on this internet gateway and this route table, this is the main route table. If you check on this main route table, you will check this route. We do have internet gateway, right? Internet gateway is already attached to this route table. Let me check this subnet. My public subnet, because we have created in this thing in public subnet inside this route, you can see that internet gateway is not allowed here. Means this we need to also allow this internet gateway here. So edit route table, right? This is by route table default VPC. So let's do one thing. Let's not edit this default route table. We will create a new route table. Acha, route table means in route table we will define how our traffic will come inside our VPC and how traffic goes outside to the VPC. Means all the inbound and all outbound rule will be allowed in this route table only. Let's create our own route table. We will not use this default route table. Create route table. Let's name this public my VPC route table, right? And we will create select VPC my VPC and create route table. We have created one route table for this one, right? Okay. Let's go to the my subnet. Inside this subnet, we'll create route table, right? Edit route table, and we will take public my VPC, right? If you check for public my VPC, let's save this. See, my VPC route table is here. Only this IP is allowed. Now we need to also allow what our internet gateway also. So let's click on this. Also, we need to associate it. It's already associated with this IPC. This route table is attached with this subnet. Association means if you check on this, click route table, and inside this subnet association means you are going to attach this route table to a particular subnet, right? So it's already attached. See, this subnet is already attached. If you check on this, no subnet is attached with this default route table, right? Because we have created a new route table and we have attached this route table to our this subnet to our route table. Now let's also allow some different rules here. Route table, edit routes, and inside route we will allow 0.0.0.0 slash this means all will able to access from this route table, and we are using internet gateway, and internet gateway is this we have created, and save changes. Now internet gateway is attached to the route table, and this route table is, if you check on this routes, you see this internet gateway is attached. Now this public route table is already attached to my public subnet, and inside this public subnet we have our EC2 instance, right? Now again check. Now everything is same. We have not changed anything here, right? This IP is same 1322. Let's goes to our terminal. Again, let's access this. See, now access is created. Yes. Now we are able to access to our instance, right? Right, guys? We are now able to access to the instance. So now we are able to access our EC2 instance, right? So means what happens as internet gateway is used, and now we were able to access through internet means through public IP. So what makes private IP and public IP, private subnet and public subnet differentiate to different from each other is that due to this internet gateway means if an internet gateway is already allowed on a VPC, if we add route of internet inside this route table, if we add this route of internet gateway for any of the subnet, then that subnet will call as public subnet, right? Now again we are going to create a new instance inside this private subnet. We are not using public subnet inside. Also, let me show you one thing. We are also able to access internet. See, let me ping google.com. Let me ping it. See, we are able to access Google, right? Means internet accessibility is there also, right? Okay, let's again create a new instance here. Right? And this time we create test2, and this time we will be creating Ubuntu image again. And instance type will be T2 micro. And let's take this as my AWS key, same key. And let's add VPC with my VPC. And this time we will be taking private subnet, second subnet, 10.0.1.0. Auto assign IP, enable it, disable it, it doesn't matter. Let's enable it for now. And we will be using different security group again. And let's launch this, right? Now we are going to launch this EC2 instance. Okay, the instance is launched. Let me check this instance. Let me refresh this panel, right? Let me also filter this name. Would be, let's start with is equal to test star. Okay, we do have two instances only. See, we do have two IPs, right? Now, if you check this second subnet, right? Let's copy this and again run the terminal here. Control D. Again, let's use this. See, nothing will happen. Also, if you check, is this security group? Security groups are same. I have used the same security group. Remember, I have used the same security group. Still, I'm not able to access because it's on the different subnet. Now, how we will be able to access this now? The question arises, how we will be able to access this, right? So let's go inside this, how we are able to access this, as public IP is also there, but still we are not able to access this because it's running on a different subnet. And also internet gateway is not attached to this subnet, right? So see, for this kind of perspective, let me first log in. Let me just log into this EC2 this test2 EC2 instance. Let me check. Let me show you this one thing. Details. Let me copy this instance. Let me copy this IP. We'll go inside this. Let me log in into my old instance only. See, let me ping this. See, internally, as you can see, we are in the same VPC, right? We are in the same VPC. And from this public subnet, we are able to access our private subnet internally. Internally, we are able to access this private subnet, right? Let me now again access inside this public subnet, private subnet. We don't have keys there. We need to copy. Let me just wait. I'm just copying this key. I'm just pausing the recording. Let me copy this key from our local instance, so I'm able to access this instance also. Yeah, I have just copied my key here. See, key is here. Let me give permission to this key 677 my key, right? Now we know default user is Ubuntu. Let's SSH-I my key Ubuntu @ let's try with public IP first. Yeah, this is our public IP. Let's try with it with public IP. Paste. See, we will not be able to access this. Now let's access with private IP. Let me copy this and access with private IP. Same thing. Paste. See, now from our public subnet, public instance, we have taken login to our private instance. See, if you check the IP will be 10.0.1.92. See, IP is 10.0.1.92. This is the IP for the private subnet. Still, public's IP is allowed. Public IP is here for this EC2 instance, but we are not able to access to public. We are able to access with private subnet internally, as it's in the same VPC. So internally, they can access privately. All the AWS resources can access to each other with privately inside a VPC. They don't use public IP, anything else. So now, as we have taken access to this, let's check if internet connectivity is there or not. Ping google.com. We are not able to access the Google. See, means internet connectivity is not there. Though we know that internet gateway is used to access our EC2 instances or any resources from internet. And if we are not attached internet gateway to our private subnet, we have not allowed our internet gateway in the route table. See, in private subnet, we have not allowed inside the route table internet gateway. In public, we have allowed this internet gateway, but not in private. So how we are able to access the internet? Suppose in the production environment or in a sandbox environment, we know that different applications are defined on different VP on different subnets, especially for DB database type of application. These applications are installed in or launched in a VPC or in a subnet where its internet gateway is not allowed. So how we are able to access the internet now, as internet gateway is not here, so how we will be able to access the internet? For this issue, for this kind of purpose, we have called NAT gateway. There is a NAT gateway introduced to resolve this issue. So we will be creating a NAT gateway now. My NAT, and we will be attaching this NAT gateway to our public subnet. Always remember to allow, means to create NAT gateway into public subnet. Public subnet means that subnet which has internet gateway. If you do this, automatically IP elastic IP will be allowed to this NAT gateway, and we have created this NAT gateway. Now NAT gateway is created, and this is created in public subnet. Right now, let's go to our subnet section. Let's take internet gateways created, not it's in pending state. I'm just pausing this video for time, right? To just check how much time it will take to create a NAT gateway. See, now it's in available state. Remember always to create NAT gateway in public subnet. In the subnet where internet gateway is attached, and in internet gateway is allowed, because if you create it on a private subnet, this will not come, this will fail to create. Now our NAT gateway is created. Let me allow this traffic to the NAT gateway. This is a public route table. Now we will create a route table for private. Let's create a route table for private. Private route table, right? And we just attaching this route table again to my VPC. Creating route table. A new route table has been created, right? Subnet association, no subnet is there right now, right? Again, click on this subnet. Let's click on subnet. And if you check on private subnet, see route table. It's default route table. It's right now our the private subnet is attached to the default route table, but I need to change this. Let's change it to the private route table, which I have created, right? I have attached this private route table to this subnet. Now it's saved. See, for this private subnet, we have a different route table now. See, right, route table, private route table, right? And only 10.0.0.16 is allowed, right? Let's go to the route table. This is our private route table. Subnet association already attached. We have attached this private route table to this subnet. Now in routes, click on routes and edit routes. Add route, again 0.0.0 traffic from NAT gateway this time. Click on NAT gateway and save changes. When you have done this changes, see, now let's check. See, internet is started. Got it? Internet is automatically started. Now it's able to ping the Google. Let me just again remove this route from our route table for this particular subnet. Edit route table. Let me remove this and save. See what happens if you check on see, let me do ping Google. See, no internet is there. See, again, let me just allow this route, edit route, add route 0.0.0.0 from everywhere. NAT gateway is here. Save changes. Now let's go again, ping this. See, internet is there. See what happened? It's not accessible from the public IP, means it's not accessible from the internet from outside the VPC, but still it's have internet. We can means traffic can go outside this EC2 instance with the help of this NAT gateway. So how this NAT gateway helps to send traffic to outside world? Through this internet gateway only. Means as we have created that NAT gateway inside the public subnet. So our traffic will goes from this EC2 instance to NAT gateway, and from NAT gateway, traffic will goes to the internet gateway, and traffic will go outside from internet gateway. This way it happens. All the traffic comes through the internet gateway in public subnet, and the traffic goes from private subnet to NAT gateway every time. And this remains every time an interview question for everyone. How this thing happens, how this thing active done, right? So that's all for today. Also, if you check in the by default VPC, if you check this subnet, inside this subnet, you will see this option, auto assign public IP IPv4 address. Yes, means when you are going to launch any instance on this public subnet, automatically public IP will be assigned, because this section auto assign public IP IPv4 address is allowed. But if you check for your subnet where you have created, auto assign public IP is disabled. See, for both auto IC public IP is disabled, but still IP is there, because at the time of creating this IP, we have creating this instance, we have allowed this IP. See, if we launch this, let me show you again. If we launch this, and we are going to launch in, suppose we are launching in VPC public. So automatically, if you launch this, see, auto assign public IP is enabled. Automatically, a public IP will be assigned there. But if you launch this in your own VPC, where you have created this, then what will happen? Auto assign public IP will be disabled. If you enable this, IP will be assigned to you, but still you will be not able to access this EC2 instance publicly or privately unless and until your internet gateway is allowed. Right? Okay.